26,000 years ago, a burst of light left the exact center of our galaxy. It has been traveling ever since, through empty space, past dying stars, through the wreckage of ancient supernovae, and it just arrived here, right now. And when NASA's James Webb Space Telescope finally caught it, scientists didn't see a calm, sleeping giant like they expected. They saw something that never stops moving, something that flares, flickers, and pulses every single hour of every single day, and has done so for millions of years without ever settling down. We're talking about Sagittarius A, the supermassive black hole sitting at the dead center of the Milky Way. For decades, astronomers assumed it was mostly quiet, a sleeping monster that occasionally twitched. But new Webb data has just shattered that idea completely. And honestly, what they found is a little unsettling. Stick around, because by the end of this video, you'll understand exactly what's happening at the heart of our galaxy, and why scientists are calling this one of the most important black hole discoveries in years. If you're new here, welcome. This is the channel where we break down the biggest developments in space, weather, and technology, minus the boring jargon. Today, we're diving into the Milky Way's very own supermassive black hole, and trust me, this one's worth your full attention. Quick refresher, in case black holes aren't your daily bread. A supermassive black hole is an object so dense and so gravitationally powerful that nothing, not light, not matter, not even time as we understand it, can escape once it crosses a certain boundary called the event horizon. Nearly every large galaxy has one sitting at its core, silently anchoring billions of stars in orbit around it. Ours is called Sagittarius A, or Sgr A star for short. It sits about 26,000 light years from Earth, roughly in the direction of the constellation Sagittarius, hence the name. And here's the number that should put things in perspective. This black hole is estimated to be about 4 million times the mass of our Sun. 4 million suns, compressed into a single point smaller than our solar system. For years, telescopes struggled to get a clear, continuous look at it. Sgr A is buried behind thick clouds of cosmic dust and gas, and it's relatively faint compared to black holes in other galaxies. That's exactly why Webb changes the game. Its infrared vision cuts straight through that dust like nothing before it, and what it found broke a lot of assumptions. One more thing before we dive in. This isn't some obscure academic footnote. This research was published in the astrophysical journal Letters, one of the most respected journals in astrophysics, and it involved teams from Northwestern University, the Space Telescope Science Institute, NASA's Goddard Space Flight Center, Macquarie University in Australia, and Harvard. When that many institutions collaborate on a single black hole, you know the data is significant. Let's talk about how this actually happened, because the observation campaign itself is wild. A team led by astrophysicist Farhad Yousafzadeh at Northwestern University pointed Webb's NERCam instrument, that's near-infrared camera, directly at Sgr A across 7 separate observation sessions between 2023 and 2024. In total, they collected roughly 48 hours of continuous data, watching the black hole in blocks of 8 to 10 hours at a time across an entire year. Now, why does that matter? Because black holes like this one don't glow on their own. They're invisible in visible light. What we actually see is the material around them, a swirling accretion disk of superheated gas and dust spiraling toward the event horizon at incredible speeds. As that material gets crushed and accelerated, it heats up and radiates light, mostly in infrared wavelengths that only a telescope like Webb can properly detect. So the team simultaneously captured data at 2 different infrared wavelengths, 2.1 and 4.8 microns, allowing them to build one of the most detailed pictures ever assembled of how this black hole actually behaves, minute by minute, hour by hour. And the picture that emerged was nothing like the quiet, occasionally active black hole scientists expected. Here's the headline finding, in the researchers' own words. Sgr A is always bubbling with activity and never seems to reach a steady state. Let that sink in. Every single observation session showed something different. No 2 viewings looked alike. According to the team, they recorded somewhere around 5 to 6 major flares per day, along with a constant undercurrent of smaller flickers happening in between, subtle bursts of brightness that never fully stop. Think about that rhythm for a second. This isn't a black hole that occasionally acts up. This is a black hole in a near constant state of turbulence, every day, for as long as we've been able to observe it, and almost certainly for millions of years before we ever pointed a telescope at it. What's actually causing all this chaos? The leading explanation involves the extreme magnetic fields tangled up in the gas swirling around the black hole. As that magnetized material spirals inward, the field lines can twist, snap, and reconnect violently. A process similar to what causes solar flares on our own sun, just on a vastly more extreme scale. Turbulence in the accretion flow itself may also play a role, essentially creating shock waves of brightness as clumps of material get torn apart and consumed. The unsettling part? Nobody predicted this level of nonstop variability. Earlier observations, using older instruments, only caught fragments of this behavior, brief glimpses that made Sgr A wanks look mostly calm with occasional spikes. Webb's extended, continuous monitoring revealed the true picture. Constant, chaotic, restless activity all day, every day. But that's not even the most groundbreaking part of this story. In April 2024, Webb did something no telescope had ever done before. Using a different instrument called MIRI, the mid-infrared instrument, astronomers captured the very first mid-infrared flare ever detected from Sagittarius A. The event lasted around 40 minutes, and it filled in a scientific gap that had existed for years. Here's why that gap mattered. Flares from black holes have been observed before in near-infrared light and in radio wavelengths, but the mid-infrared range, sitting right between those two, had never been properly captured. It's technically difficult because even faint atmospheric interference from Earth can wash out this kind of signal. You basically have to observe from space to get a clean reading, and until Webb, no instrument had the sensitivity to pull it off. By catching this flare specifically in the mid-infrared range, scientists were able to observe something remarkable. As the flare evolved, the emitted light shifted, becoming brighter at longer wavelengths as the electrons in the surrounding plasma cooled down over time. Researchers also detected a radio echo of the same event, appearing shortly after the initial flare, a delayed signal that helps map exactly how energy moves outward from the black hole after an eruption. Piecing together near-infrared, mid-infrared, and radio data from the same event is like finally getting all three witnesses to the same car crash to describe what actually happened. Each wavelength tells part of the story. Together, they're rebuilding the full sequence of how a black hole flare is born, evolves, and fades. So why should any of this matter to you, sitting there watching this video on a random weeknight? Because Sgr A is essentially a natural laboratory for physics, we cannot recreate anywhere on Earth. No particle accelerator, no experiment, nothing built by humanity can replicate the conditions found at the edge of a supermassive black hole's event horizon. By studying how it flares, how its magnetic fields behave, and how matter is consumed, scientists are testing the outer limits of Einstein's general relativity. The same theory that underpins GPS satellites, satellite communications, and a huge chunk of modern technology. There's also a bigger picture question here. How do supermassive black holes influence the galaxies that host them? Growing evidence suggests these objects aren't passive backdrops. They actively shape star formation, regulate gas flow, and may even influence how entire galaxies evolve over billions of years. Understanding the personality, so to speak, of our own galaxy's black hole gives researchers a benchmark for understanding thousands of others across the universe that we can't observe nearly as closely. And this is genuinely just the beginning. The same research team has already stated their intention to push further, aiming for an uninterrupted 24-hour observation window to cut through background noise and catch even fainter flickers they may have missed. The goal is to figure out whether these flares follow any kind of pattern, or whether they're purely random, chaotic events with no underlying rhythm at all. If they're random, that tells us something. If they follow a hidden pattern, that could reshape black hole physics entirely. Now, let's address the elephant in the room, because disturbing doesn't mean dangerous. 26,000 light-years is an almost incomprehensible distance. For context, our entire solar system is roughly one light day across. Sgr A's flares, no matter how violent, have zero physical effect on Earth. We are not in any danger from this object, now or in any meaningful future timescale. What's disturbing isn't a threat to us. It's the scale of what's constantly happening completely unnoticed, right at the anchor point of our own galaxy. Every single day, matter is being torn apart and consumed by something so powerful it warps space itself. And until now, we had almost no idea just how relentless that process actually was. It's less monster under the bed, and more a reminder of just how small and quiet our corner of the galaxy really is compared to what's churning at its core. It's also worth remembering just how young this field of study still is. Humanity has only had a clear infrared window into the galactic center for a few short years. Before Webb, our best images of Sgr A came from ground-based telescopes fighting through Earth's atmosphere, or from the event horizon. Telescope's famous 2022 image, which showed the black hole's shadow, but couldn't capture this kind of rapid, ongoing variability. We are, quite literally, watching the opening chapter of a brand new era in black hole science, and every new observation session seems to rewrite part of what we thought we understood. Here's my honest take. What Webb captured isn't disturbing because a black hole is coming for us. It's disturbing because of what it reveals about the sheer chaos sitting at the center of our galaxy. Every 26,000 years or so, light from right now is leaving that region. And it won't reach Earth until long after every single person watching this video is gone. And in that time, Sgr A is flickering, flaring, devouring, completely indifferent to us. That's the real gut punch here. We are 26,000 light years from an object so extreme it bends the fabric of space itself, and Webb just gave us a front row seat to its constant, restless behavior. If this doesn't put your Monday problems into perspective, I don't know what will. My verdict? This is one of the most important and most unsettling discoveries Webb has made so far, not because we're in danger. We're not, but because it proves that even the quiet center of our galaxy is anything but quiet, and we're only just beginning to understand what's really happening down there. So here's what I want to know from you. If you could safely see Sagittarius A up close, no risk, no danger, would you actually want to look? Or is this one of those things that's better left a mystery? Drop your answer in the comments. I read every single one. And hey, if this video expanded your view of our galaxy even a little bit today, do me a favor and hit that like button. It genuinely helps this channel keep making videos like this one. Subscribe if you want to be here next time we uncover something the universe has been hiding from us. I'm Kenzo, and like and subscribe my Chanel Planetary Report, and I'll see you in the next one.